All right, so let's start with this. This is the quiz from Monday, and you're not seeing it. There you go. So this is the quiz from Monday. So we're going to use this as an example. You should already have this paper. If not, I'll almost go post all the answers and stuff later. All right, so for question 1 to 5, you're using the spinner. So what's the probability of getting a 6? Remember, P of 6 just means the probability of getting exactly 6. There's only one 6 here. So it's one possible winning slot from 12 total slots. So your probability is 1 over 12. Again, you can leave it as a fraction. If you really want to change it to a decimal or percentage, that's fine. The next thing, what's the chances of being shaded? So now you got to count what are shaded. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 shaded out of a total of 12 possibilities. Reduce that. That's going to be 2 over 3. Next one, we're going to do a prime number. Please remember, prime numbers are numbers that only multiply by itself and 1. 1 is not a prime number. It's not 1 and itself. It's just 1 and 1. Yes. 2 is a prime number. 3 is a prime number. 5 is a prime number. 7 is a prime number. 9 is not a prime number. That's 3 times 3. 11 is a prime number. So in this case, you have 5 choices out of a total 12 in total. So it's 5 out of 12. You cannot simplify that. The next one, we're going to do odd or unshaded. Odd or unshaded. So let me mark all the odds. So 1, 3, 5, 7, 9, 11. And just for prosperity's sake, let me mark all the shaded. This is shaded, 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 this is shaded. In an or statement, even though, let's say 11 is double counted, you don't double count it in the possible winning. The only amount of wins you have is 1, 2, 3, 4, 5, 6, 7, 8. There are 8 pieces that win. Even if some of them are double counted, it does not double count in the amount of winning slots you have. Now, the next one is multiple of 3 and even. So I'm saying and. So it has to be both. So first, multiples of 3. So that's 3, 6, 9, 12. And then evens. So that's 2, 4, 6, 8, 10, 12. In this case, they both have to exist. In the or statement, I don't care if it had 1 or 2. In this statement, I need both of them. So the only ones that fit that is 12 and 6. So that's 2 out of 12, or 1 out of 6. So and statements, you have to have both be true. Or statements, you can have one or the other. All right, if a letter from the word administration is selected at random, what is the probability is not a vowel? So first off, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 letters. So I know the bottom of my fraction is going to be 14. All right, now it's not a vowel. So you either could count the consonants, which is fair, or what I'm going to show you is I'm going to count the vowels. So that's A, I, A, I, O. So that's 1, 2, 3, 4, 5, 6. So 6 of them are vowels, which means not vowels should be what's left over. 14 minus 6, 8 numbers. So it's going to be 8 over 14. If you want to just count the constants, that's also fine. But just know a not statement, you could just subtract it from the total. So 8 out of 14 is 4 out of 7 after you simplify. Number 7, the probability of picking a pink jelly bean out of a bag, which is 4 out of 15. What's the probability of picking not a pink jelly bean? So kind of what I mentioned, since out of the 15 jelly beans in the bag, 4 of them are pink, that means everything else is not pink. So it's 11 out of 14, or 11 out of 15, my bad. So 11 out of 15. Next one. The spinner below is spun 40 times. Keep that in mind. What is the rates? Results are shown in the table. So you should know that this is a total of 40 things, okay? All right, theoretically, what is the probability of spinning landing on green or yellow? Remember, it's or. So green or yellow on a single spin. There's only one green and one yellow, so that's 2 out of 5. That's 2 out of 5. Based on the experiment, since I'm talking about the experiment, I'm talking about the table. If I'm talking about theoretically, I'm just looking at the spinner, okay? Since the experiment, what's the probability of the spinner landing on a green or yellow on a single spin? So I got to look at my greens and I got to look at my yellows. 12 plus 6, or 18 in total, which is green and yellow, out of the total amount that I spun, which I said it earlier, or you could just add them all up, 40. Okay? Simplify that. That's 9 over 20. So, oh, that's it. So then it's just going to be 9 over 20. Okay? I might ask you a question, so pay attention to this. Compare the two. Are you more lucky or less lucky in this situation? If you need to compare the two, what you want to do is change them both to percents. The best way to change something to percent is divide the top from the bottom. If you take your calculator and do 2 divided by 4 or 2 divided by 5, you get 0.4. 0.4 as a percent is 40%. Okay? Over here, if you did 9 divided by 20, you would get 0.45. As a percent, that's 45%. So if I ask you, are you more lucky or less lucky in this situation? You were more lucky. You got it more than what you were supposed to get, which is 40%. Okay? So I could ask you to compare the two. That's a possible choice. Next one. Theoretically, if a spinner spun 500 times, how many times do I expect it to land on orange? Since I'm talking about theoreticals, I'm looking at the spinner. So how many oranges are there? There's only 1 out of 5 oranges, which means I'm going to multiply it by the 500 times I do it. Since 500 is a whole number, I could just put it over 1. So it's 500 divided by 5, or 100 times. So I expect to hit orange 100 times. Based on the experiment, if the spinner was hit 500 times, how many times do you expect it to land on orange? In this case, if the experiment is the table, I'm looking at it. I have 5 hits over 40 attempts, okay? Which I can simplify to 1 over 8. Then I times that by 500. So 500 divided by 8, which should be 62.5. So 62.5. In this one, I can compare, are you lucky or unlucky in this case? No, this case you're unlucky. You got less than, you were expected to get 100 times. You only got it 62 times. 62 and a half times. So you're pretty unlucky. You're like short 40-ish. Okay? All right. A penny is tossed and a standard die is rolled. Draw a tree diagram. So a tree diagram of this thing is you have to think of your first event. Since a penny is thrown, we're going to call that coin 1. And then a die is rolled, so we'll call this die 1. All right? So if a coin is thrown, what options are there? Heads and tails. So heads and tails. When a die is thrown, from heads, what could happen? I could get a 1, 2, 3, 4, 5, 6. So I could have heads 1, heads 2, heads 3, heads 4, heads 5, heads 6. I could also have, I'm just going to put it over here to give space, tails 1, tails 2, tails 3, tails 4, tails 5, tails 6, tails 1, tails 2, tails 3, tails 4, tails 5, tails 6. This is all coming from tails, okay? Which means if you just count the edge over here, you have 6 plus 6, or 12 total outcomes, okay? Now, when they say write the sample space, this is an example of sample space. So on the test, I will give you the choice of drawing the tree diagram or the sample space. The sample space is, I could get a heads and then a 1. I could get a heads, then a 2. Heads, then a 3. Heads, then a 4. Heads and a 5. Heads and a 6. I could also get tails as a 1. Tails as a 2. Tails as a 3. So whatever one you want to write, I don't care which one you write. Whatever's more convenient for you. Tails with a 5. Tails with a 6. And again, if you were to count it out, that's 12. So how many outcomes are there? 12. Okay? If I ask you, though, What's the chance of getting tails and less than 5? So it has to be tails and it has to be less than 5. The only ones to fit that is tails 1, tails 2, tails 3, tails 4. So it's 4 out of 12 or 1/3. Okay? All right. 1 divided by 3. I do teach math a lot.
That's crazy. Do you ever get a clap? I'm giving you a clap. And we got like snacks and candy, chocolate.
A card is selected from a standard deck. On your test, I'll make sure there's no standard decks because I know some people just don't know cards. So it'll be like bag of jelly beans or something like that. It will always be clear. But we'll still work with this. A standard deck and a day of the week. So a standard deck has 52 cards. Less than 5? But it's tails and less than 5. So it has to be both tails and less than 5. If it was just less than 5, yes, you were right. It'd be 2/3. So 52 times 7. 52 times 7, because there's 52 cards in a deck, and there's 7 days of the week. So you just multiply it out. 364. Okay? How many 5-digit zip codes are in there? So in this situation, the first number, let's say some number, I can have a choice of 10 numbers, right? 0 to 9. The second number could also be 10. The third number also has 10 choices. Fourth number, always 10 choices. Fifth number, always 10 choices. 1 through 9 plus 0. So it's 10 choices. So it's 10 times 10 times 10 times 10, or 10 to the 5th power, or 100,000.
This stuff is on the test on Friday too.
That's 6 digits.
It's 5 zeros. The 1 is the leading digit. That's the quick way to do 10 to the 5th power, or 10 to any power, right? It's how many zeros you have. 10 to the 1 power is 10, right? So that'd be 1 0. Oh, okay. Go on. All right.
You guys are leaving. Where are you going?
You don't have to
You
ask.
say you could go. I run this class.
Don't joke. So, the spinner is spun twice, okay? So how many outcomes are possible? So in this case, the first choice, I have 8 outcomes. The second spin, it doesn't remember what the first spin did, so I have 8 outcomes again. So it's 8 times 8, or 64 possible choices, okay? What's the probability of getting F both times? So the probability of getting the letter F, which is only 1 out of... Good, so the probability of getting 1 out of 8, and again, the probability of 1 over 8, so 1 over 64. What's the probability of getting the D? So that's going to be 1, so 1 out of 8, over the probability of getting the vowel. So the vowels are A and E. So it's 1 over 8 times 2 over 8. That's going to be 2 out of 64, or 1 out of 32. All right, the spinner is spun once, and a month of the year is selected. How many outcomes are possible? Since the spinner has 4 options, that's our first slot, and then a month of the year, there's 12 months of the year. 4 times 12, that'll be 48. What's the chance of you getting a dime in the spinner? Then a month that has no more than 30 days. I will not use a prompt like this because that forces you to know every month of the day. At worst, I would just probably say, what's the chance that your month starts with a J? Okay, or something like that, or N. So dimes, that's 1 out of 4 because there's 1 dime in the 4 shots. And then I think it was like 5 out of 12 for the months that have no more than 30 days. So it ends up being 5 over 48. What's the probability of a coin that has at least 5 cents? So it's a nickel, a dime, and a quarter.
It at least includes 5.
Yeah, because I have at least 5 cents. I could have 5 cents.
When would it not include it? What would it say if it doesn't include 5 cents?
If I meant the same direction, yeah, more than 5. More than 5 cents. And then September or October. So there's only 2 months there are September and October. So 2 over 12. And then that's going to be 6 over 48 or 1 over 8. The only thing that's not on this quiz I'm going to talk about is, let's say if you had a bag of jelly, I'll type it out. If you have a bag of jelly beans or something, bag of rocks, where there are 5 blue rocks, 4 red, and 6 yellow. Okay. You pick 2 rocks without replacement. AKA, you're going to keep the 2 rocks, okay? So if I ask you what's the probability of getting blue, then blue, okay? In this scenario, I would have 5 blue out of a total of, if you add it up, 15 rocks. But times the second time I pick a blue, I didn't put the blue rock back into the bag, right? So my blue count of rocks went down. So there's only 4 blue rocks left in the bag because I already took one. And there's only 14 rocks in total because I already took one. So it's going to change to this, which is going to be, this is 1/3, this is 2/7, so it's going to be 2/21. Okay. If I said, what's the probability of getting yellow, then red. So in this scenario, I have yellow, which is 6 out of 15, and then red, which is 4 out of 14. I still took a rock out of the bag. Okay, I still took a rock out of the bag. So that is going to be, we can simplify this to 2/5. We can simplify this to 2/7, 4/35. Okay. So remember, if I ask for no replacement, or some reason you would lose something as you keep going, then it reduces the fraction as you go forward. So don't forget that, okay?
Wait, what?
So like in this situation, I said there's no replacement, right? I'm not putting the rock back. So because the rock doesn't go back, the overall goes smaller. And depending what I picked first, the total might go smaller too. Okay? This is something that didn't show up here, but would be on your test, okay? Hopefully this helps.